Alright, so I've been having some questions with Lab 8 on how to do some of these problems, so I wanted to go over a sample problem similar to problems 4, 5, and 6 on Lab 8. So I'm going to do an example problem with a different chemical formula and just work through the steps so you can see how to approach these problems. So I'm going to start with a chemical formula of C2H6. And we have 12.9 grams of that molecule. So from there, we need to calculate the moles of C2H6. So if you remember, to calculate moles, we need the molar mass. Okay, because molar mass is measured in grams per mole. We use that as a conversion factor to go between grams and moles. So my first step that I'm going to do off to the side here is I'm going to calculate the molar mass of C2H6. When we calculate molar mass, we make a list of all the elements present, in this case, carbon and hydrogen. We then write down how many atoms of each element, and to figure that out, we look at the subscripts. So after the C, there's a subscript of 2, so that's how many atoms there are of carbon. For hydrogen, there are 6. We're going to take those numbers then and multiply by the molar mass. And the molar mass we get from the periodic table. It's that atomic mass, that average atomic mass that we talked about in chapter 3. So for carbon, when I look that up on the periodic table, it is 12.01. For hydrogen, it is 1.008. Get my calculator out here. So multiplying that across, I get 24.02 from carbon, and I get 6.048 for hydrogen. So I need to add those two numbers together. So let me get my calculator out, and we get 24.02 plus 6.048. Okay. So I get 30.07. And the units on that are grams per mole. So I'm going to write this off to the side like a conversion factor. So I have 30.07 grams is equal to 1 mole. So this is going to get me from the grams that I have here 2 moles. So I'm going to write CF here because this is my conversion factor. I'm going to erase this, give myself a little bit more room. Okay, and now I will start with my conversion. So I'm doing moles of C2H6. That's what I'm trying to calculate. So I'm going to start my railroad tracks, and I always start with the number given in the top left corner, including the units. And then I'm going to take this conversion factor and plug it in here. I want to put the grams on the bottom so that they cancel, and then the moles on the top. That gets my grams and my grams to cancel. And once I calculate this out, I get 0.429 moles. So this would be the answer to moles of that molecule. Notice I did 3 significant figures because my original number also had 3 significant figures. Now let's do the next step and calculate molecules. So to calculate molecules, we need another conversion factor, and in this case it's going to be Avogadro's number. So I'm going to write that conversion factor down here. Avogadro's number is 1 mole is equal to 6.022 times 10 to the 23rd. And in this case it's molecules because we are looking at a covalent compound, and so the term entities becomes molecules. See, I spelled that wrong, but you get the point. Alright, so when I start this conversion, I'm going to start with my moles that I've already calculated. Running out of room there. So I got 0.429 moles. Then I take this conversion factor, Avogadro's number, I put the 1 mole on the bottom, and then the 6.022 times 10 to the 23rd molecules on the top. My moles and moles cancel, and when I do that calculation, I get 2.58 times 10 to the 23rd. The units on it are molecules. So these first two sets you've probably done before. We did them in class already, so you've seen me do these types of calculations. It's the next few examples that are going to be a little bit different. So I'm going to erase what we have done so far, but I want to leave this number, molecules, here because we're going to use this in the next few steps. I spelled molecules right. Okay. So the next questions ask now for atoms. Okay, so if we wanted to figure out atoms, how many carbon atoms are present, how many hydrogen atoms are present, we're going to need to use a mole ratio. Okay, so before when we've looked at a chemical formula, in this case C2H6, that says we have 2 carbons and 6 hydrogens. Okay. Then if we decide, okay, well say I have 2 C2H6. To figure out how many carbons now, I'm multiplying. I'm taking that coefficient and I'm multiplying it by the subscript to figure out total carbons. So 2 times 2 says I have 4 carbons. 2 times 6 is going to tell me that I have 12 hydrogens. So we can use this same process and apply it to molecules. So let's look and see how we're going to do that. So let's erase this. And say, instead of 1, instead of 2 C2H6s, say we have 2.58 times 10 to the 23rd molecules of C2H6. Okay, so how many carbon atoms do we have? Well, we're going to calculate that the same way we did when there was a whole number here. It's just now we don't have a whole number, now we have a giant number. So we're going to take this 2.58 times 10 to the 23rd, and we're going to multiply it by the subscript on carbon. I have 2 carbons, so I'm going to multiply that by 2. And I get 5.17 times 10 to the 23rd carbon atoms. All right, let's do the same thing now for hydrogen atoms. So how many hydrogen atoms? Well, to figure that out, I'm going to take how many molecules I have and multiply it by the subscript, this time on hydrogen, because that's the element I'm talking about right now. And in this case, the subscript is 6, so multiplying that by 6, is going to give me 1.55 times 10 to the 24th atoms. All right, so let's look at this in a different way, because usually we've been dealing with conversion factors and it's nice to see what you don't want cancel out and what you do want stay. So I'm going to solve these again in a slightly different way. So let's go back to that mole ratio thing where we looked at, Okay, we have C2H6. Say we have one molecule of that. That means we have 2 carbons and 6 hydrogens. All right. Well, let's now add the word atoms here. And I'm going to add the word molecules here. So if I want to figure out how many carbon atoms, let's do my railroad track. And the only piece of information I have is how many molecules. So that's what I'm going to start my railroad track with. So I'm going to start it with my 2.58 times 10 to the 23rd molecules. And now I'm going to use a mole ratio here. That's what my conversion factor is going to be. It's going to be mole ratio. Since I'm trying to figure out carbon, I need to use the mole ratio between carbon and C2H6. And that ratio is 2 atoms of carbon to 1 molecule of C2H6. Look familiar? It's a conversion factor, right? So I'm going to take this conversion factor and apply it here, and I'm going to put the molecules, what I don't want, on the bottom. What I do want, the carbon atoms, is going to go on top. Molecules of C2 cancel, molecules cancel, multiplying 2.58 times 10 to the 23rd times 2 will give me my atoms of carbon, which we've already solved, and you'll get the same answer because we did it the same way, just the conversion factor method instead. So we still get 5.16 times 10 to the 23rd. All right, well, I hope that is helpful and you are able to go through those problems with a little more ease. Let me know if you have any other questions, and I will try to record some tutorials and hopefully get a better system going. All right.